Hi, everyone. Welcome to 2018, the year of web components. Before we kick off, and I hope this stage really stays because it's shaking, and so if you don't see me move much, that's mainly because I'm afraid that the stage drops down. Let's start with a question, and I might see your hands, I might not, hopefully. So hands up if you, at any point in your career, had to write front-end code. Cool, that's pretty much everyone. I expected that, but keep your hands up if at that point you had to write a date picker or a custom select box at one point. All right, that's also pretty much everyone for the people who are watching on the overflow room. And, you know, that's the problem right there. Like, I've done the same thing, and in fact, if you search on NPM, there's over 1,000 modules that solve date pickers. And there's everything from generic date pickers to date pickers for React and date pickers for Vue.js. And there's not just one date picker for React, but a million date pickers for React. And that's just really complicated, and you have like a big amount of fragmentation. Because first of all, date picker implementing date pickers isn't easy. So why don't we have a way to just use a date picker like we use any other element that is native to the browser, like a video tag or an input tag, like a text box. And this is pretty much where web components come into play, and the idea is that we can use a UI concept like date pickers, just like that. And over the next hour, I would love to talk to you about why I believe that 2018 is sort of where we want to look into web components more and where they're really going to take off. And if you've been around the web development community for a while, you might have heard the same statement in 2013 or even in 2011 when the web components idea was initially announced. However, I really think that 2018 is really the moment where we want to start looking at it, and hopefully by the end of the talk, you're as excited about them as I am. But before we get started, let me quickly introduce myself. I'm Dominik. I live in Berlin, and I work as a developer evangelist for a company called Twilio. We're a cloud communications platform, so we have different APIs for developers to solve different communication problems, such as sending SMS, making phone calls, chat, video, etc. If you want to talk more about that, we actually have a booth downstairs, so you can come by later, ask me any questions about the talk, or also about Twilio in general. So I've been developing for the web for a while now, and at every point in time, sort of we had the same problem, and that was how do we share UI concepts and in general like UI solutions between projects. And there were different approaches developed over this time. One of them I call the Bootstrap approach. So that's basically you take a bunch of CSS and JavaScript that is typically hosted somewhere on some CDN. You blindly copy paste that from the documentation because you're like, I think I need all of them, even though they say optional, but I'm not really sure which ones are optional, so I'm just going to copy all of them. And once you have done that, then you go back to the documentation, you pick out your favorite component you want to take, and then you copy paste that code, and then the puzzling starts. So you want to have an alert box, cool. You copy paste this, but now the question is, so which ones of these are styling related, which ones are mandatory, which ones are optional, which ones are semantical, which ones help you with accessibility, you know, like, and which ones do I have to keep up to date at which point, you know? Do I have to have the HR in there, or will the entire thing flip a table if I remove it? What's MB0, you know? Like, if you don't spend a lot of time with that, you have no idea what that does, versus like alert heading, that still seems sort of reasonable. But does that have to be an H4? Can it be an H5? Because in that context there is already an H4, and I still want to have semantical HTML. So there's a lot of these things that are kind of really unsure, and you shouldn't really have to bother with. So there's another approach, which is more the JavaScript API or SDK approach. So in this approach, we load some global JavaScript, and then in this case, the Google Maps API, and then we specify some way that it is being triggered. So in this case, we declare a global function that is automatically being triggered when the script has been fetched. And then in there, we use some global SDK where we specify a DOM element that has to be already present, which sort of acts like a container. and then pass some options in, and magically the SDK places a bunch of stuff in there that we can configure. While this is a cool approach because it abstracts away the things that we don't have to care about, there's a lot of things going on here that are not really compatible with modern web development, how we do it. So first of all, this requires DOM access. That's something that libraries like React or Angular really don't encourage you to do, because this will be very difficult with server-side rendering, for example. The other thing is global functions. We shouldn't really use that. And all of these concepts really don't create a nice user experience here. And then there's another alternative approach, which is sort of like the share button approach from Facebook. And it's a mixture of loading some global JavaScript. And this just looks really confusing because they do asynchronous JavaScript loading without using the async and the defer attribute by kind of like just injecting the script manually. And once that actually happens, then you have to place somewhere on your page some HTML that has to have a specific shape, so similar to the Bootstrap one, by having a class, in this case FB share button, so the SDK knows what to look for. And then you specify a bunch of data attributes that then will be read by the SDK and magically placed in this button. The cool thing about this is that we can have a fallback in this case. So if the SDK isn't being loaded, in this case, we can put an A tag there, and that will just work. However, we also see here that at this point, we already have duplicate code because we have twice the same URL that we need to keep in sync, and it's very easy to kind of like overlook this. So overall, all of these approaches work pretty well if you write plain JavaScript, but you quickly end up with a poor developer experience when it comes to combining this with frameworks like Angular, React, Vue, pretty much all of them, because it requires you to access the DOM in a lot of cases, which is actively discouraged, and or it requires you to load in a bunch of, copy-paste a bunch of stuff. So we quickly end up writing wrapper components around these things. However, these wrapper components are always kind of bound to the respective framework where we want to use them. And that quickly kind of creates a fragmentation in the way that we have things that are out of sync, different features are in different wrapper components. So if we look at something like MDL, which is Material Design Light, so you can imagine that like the Bootstrap equivalent for material design. So it has some global style sheets, and it has a global JavaScript. And people wrote wrapper components around this, and there's one for Preact, there's one for React. But for example, these two, even though they're relying on the same Bootstrap style library, they have completely different features. They have not only different syntax, but like they have completely different feature coverage. Same goes on for Vue and stuff. And what if they kind of go out of sync because like one of them is keeping up to date with the security patches, the other one is not being used anymore because it's driven by someone from the community and they don't really care about this anymore because they moved on to another project. So all of these kind of really create a poor developer experience. So what if we could instead use custom, use elements and components as if they are just native to the browser? What if we can actually extend them from the built-in HTML element? And this is where web components come into play. And web components, contrary to like a popular belief, it's not just one spec, it's actually a series of specs. So it's a series of 4 specs. The first one is called custom elements. And it's probably the thing that most people associate with web components. So custom elements is this concept of allowing you to extend the built-in HTML element to declare your own elements and HTML tags. And when I'm talking about extending the HTML element, I mean that quite literally. So you would define a new ES 2015 class. It has to be an ES 2015 class. You can't do the prototypal inheritance with functions here. And then inside the constructor, you can then kind of make your own magic and kind of place things into that attribute and start rendering things. And then later, you just call custom elements.define, specify a tag name, and specify this class. And the browser will register this for you so you can use it. The cool thing is you can also extend other built-in elements. So if you would want to extend the input element instead, you could do that. You would instead extend from that class, and then you would specify an attribute called extends input to the custom elements. And both of these can be used the same way. You can use them as declarative, as you're used to via HTML. So you just use either, if it's a normal custom element, you just use the HTML tag that you define. And otherwise, if it's an extending one, you use that base tag and you write is equals and then the name that you defined. And then you can also use them imperatively via JavaScript. So you can just use document or create element. And this is really cool because things like the VDOM from React and Preact, they just call document or create element under the hood. And all of these sort of libraries do. So because they anyways have to deal with things like input and video and stuff like that. So there's no additional magic here. It just works. If we talk about custom elements, one thing you should keep in mind when you're building them is the difference between attributes and properties. If you're not familiar with the difference, basically an attribute in is the ones that you define in HTML. And these can allow you to pass information into a component, but they only support simple data. So that means we can pass in things like string, or we can check if the property is generally available. We could sort of stringify data and then place it in, but since we would constantly have to parse it, that's not really performance, so typically you rely on basic data here. And then there is properties, and properties are really the properties on an instance of this class. So, for example, the value here, the equivalent would be the equivalent property would just be like we grab out the element out of the DOM and then call .value. Similarly for like disabled, but we could also pass more complex data, like an array, for example. And the thing here is that these two are not directly connected. We can connect them, and we can make these reflect these changes, and that's what you would typically see with built-in elements. But you have to do it manually. So it would look similar to this, where you would define, instead of just a plain property, you would define a setter and getter, and then these would sort of take care of reflecting that change back into the attribute. There's also lifecycle hooks in the HTML element base class, like attribute changed callback, so you can kind of listen on when attributes changed and then kind of reflect that back into properties or handle events on this and stuff like that. The next spec is HTML templates. So that allows you to create HTML that is very easily and very performantly duplicatable. So you would use the HTML template tag, and then inside there you can specify a bunch of different HTML and CSS and things, and they won't be rendered, so you don't have to worry about that. But the nice thing is you can grab this via the query selector or document or get element by ID, and then you can clone these nodes very efficiently. So we do that by grabbing the content and then calling .clone node on this, and in this case we're doing a deep clone. And then we can kind of really easily stamp out new instances in a very performant manner. This is the most performant way to duplicate the same thing again and again into the DOM, because it's directly powered by the browser. And one thing you see here is a slot attribute, and we'll cover that later, but this is one thing that you can use in templates as well. So then there's the shadow DOM, and the shadow DOM allows you to hide underlying implementation of your custom element, for example, and scope styling. So a good example for this would be the HTML video tag, or really like any of the built-in elements that are not that are doing some styling to it, right? Because we want to make sure that, for example, if you're overriding the styles for every button, the play button on a video player shouldn't directly be influenced by this. And this is what the shadow DOM kind of ensures. The way you use it is you use it in the constructor of your custom element, and you just call this.attach shadow. In this case, we're using the open mode, and you will see later how that looks like. And then we append just the content, in this case, from the template that we grabbed earlier. We just then clone that into the shadow root. And then that sort of appears like this in the dev tool. So the top one is how we would write it in code. We would create a date picker. We could pass in some child component. And then once that's rendered, we actually have these like the content that we pass in as a child appear in the slot. And it's not going to be actually placed in there, but it's going to appear at that position. And we're going to see later in an example how this looks like in case this is a bit too abstract for you right now. And then there's the fourth one, and that's HTML imports. And that's the one I'm not really going to dive into because it's essentially declared dead. The idea here was to find a way to include all of these things like HTML templates and JavaScript and stuff like that, and CSS, all of that into another website in an easy way. And the idea was, well, HTML already understands all of these things, so why don't we just do a way to import HTML? In the meantime, we didn't really see adoption for that in the community, so as a result, the team working on it kind of like declared it dead, and instead right now everyone is focusing on JavaScript modules. There is the discussion around HTML modules, but they're still in a very early stage, so we're not going to cover those. So how does the support look like? So the support is pretty good if you use polyfill. So most of the things that I talked about, like HTML templates and ES modules, are actually in every evergreen browser these days. Custom elements can be actually really well polyfilled. Shadow DOM is the more tricky one. So there is a polyfill called Shady CSS, which will kind of try to do this scoping of the styles, but there's just certain things that are just not polyfillable there. So you still have to kind of write very good CSS there until Shadow DOM support is there. However, the polyfills certainly help you to onboard this quickly so that once the browsers finish the implementation, your component just works. So why should you care? Why should I care? Why should anyone really care about this? So if you develop a UI component, web components is definitely the best way for you to get larger adoption. If you're writing your component for React only, you're excluding a large user base of Vue and Angular users. And really anyone who builds a static website. There are still a lot of use cases for static websites, especially in things like marketing, etc. And even if you don't write UI components for the world out there, it allows you to share the same tools, the same components among your teams in your company. So if you're working on sort of like the brand guidelines and stuff, like I used to work at Microsoft, and everyone in the Office org kind of implemented their own version of the very same button. And this is sort of a lot of redundant code. And you kind of continue doing that again and again every time there's new brand guidelines. Why can't every department sort of use the same button? And even if you don't fall in that category, like other people developing web components and onboarding to web components just creates a better development experience for you as well, because every framework knows how to handle native elements, and therefore that's always something that has a good developer experience in every framework. To show you a good example of web components, I want to talk about A-Frame. So if you're not familiar with A-Frame, I'm not sure, how many of you heard of A-Frame? All right, that's not too many. So A-Frame is an abstraction layer around Three.js and WebGL. And it's there to enable you to build really easily web VR experiences using simple HTML markup. I'm going to quickly show you a demo here to show you why this is really useful. So this is an A-Frame example. It's on Glitch, and the link is in the slides, so I'm going to share that later if you want to play around with this. But we can do these things like walk around and stuff, and it's really cool. But writing this code in WebGL would be incredibly complex. Writing this code in Three.js is still a lot of code and very complex. However, if we look at the code here, we see already there's a license file, a README file, and then just an index HTML. There's no JavaScript, there's no package JSON, there's no build pipeline, there's nothing like that. This is all the code for what we see. And it's readable. Like I can, even if I'm not an expert on WebVR, I know how to use this, and I can go like, all right, there's like hello A-Frame here. So if I look back here, it says it there. So I should be able to just go here and say hello. And it's the Oslo. And we can change the color here. So let's, I don't know, make this bright green. So stay like this. And Still loading. Oh, anyways, let's just keep this. There we go. Ah, it was there. Internet. It's loading. So it has to fetch the other resources. Let's try this again. Anyways, but it's really easy to kind of understand how all of these things play into each other. And even if you're not an expert on this, you're able to play around with this. Another good example is a web component my colleague Phil Nash wrote, which is about the web share API. And it's a progressive component, and I think it highlights a really nice concept. So this is how you would use his web component, and it uses the web share API, which is an API designed to make sharing things on the web easier, especially if you're on mobile and things like that. So you can just click a button, it opens the kind of share dialog that you're used to from native apps, and you can specify a bunch of properties here. But then he also allows you to specify child components, and in case web components are not supported at all, it will just drop back to those child components, because the browser will just treat the web component as a div tag, so it's going to ignore all of that. But if it does support web components and it does support the web share API, then we will get an even better experience for the user, because they can actually get the native share dialog. So if web components are great, why? And we've been talking about them so long, why didn't they take off yet? And there are multiple reasons. First of all, browser support. So it took a long time until the spec was sort of finalized, and then the browser started implementing it, but it took a very long time. Like the V0 spec was around for a long time, and now we finally have a V1 spec that is being implemented by more browsers than just Chrome. And then the other thing is it's a very low-level API, similar to WebGL. Those are APIs that typically you wouldn't want to write kind of the code manually for, because like I showed you the example of how to keep attributes and properties in sync, and that's just for one. Imagine you have to write this for every other property of your web component. But the reason why we have a low-level API has to do with something called the Extensible Web Manifesto, and that's a manifesto that was created by all the browser vendors to kind of agree on how they spec new features for the browser. And there are two particular things in there that explain why we work with low-level APIs these days. The first thing is that they agree on that they should focus on adding new low-level capabilities so that they can create secure and efficient APIs. Because if they would focus on speccing a date picker and then ship that date picker, everyone would just complain about, like, that's not the date picker we wanted to have. You know, like a good example is the select box. How many of you try to style the actual built-in select box? It's not that easy. It's not what we wanted. So instead, we end up writing our own anyways. And then these low-level capabilities should explain an existing feature, such as HTML or CSS, and they should allow the authors to understand and replicate them. And that's exactly what we see with specs like WebGL, which basically is like the access to the renderer, or things like the Web Components APIs, which literally just explain how every native element is built. Like, it's the same way as how input tags, how video tags are built, is how web components are being built. If you want to learn more about that and why like the specs of the web components took so long, that's an entire talk by Monica that is really great. It's called How the Web Sausage Gets Made. So I highly recommend you check that one out, because I don't have time to cover all of that, and she did a way better job about that. So if it's a low-level API, we want to have great tooling, because there's a reason why we write tools around things like WebGL, so there should be great tools around web components as well. And in the past, your options look pretty much like this. You wrote native web components, or you used Polymer. And that was pretty much it. And Polymer was the only thing really driving for the adoption of web components. But the landscape these days looks completely different. So those are just a few options, and only some of the options that actually had logos. So this is, you can pick between things like web components and Polymer still. Polymer is now in version 3 and drastically changed from what they looked like in version 1 and 2. And their goal is to be redundant at one point. They just want to drive the adoption of web components. So don't get confused and think they just really want you to drive for getting building all your apps in Polymer. They just really want you to build web components. But you can also use things like Glimmer, which is the rendering engine inside Ember. So that's the logo on the top right. You can use something like Skate, which is the bottom left one. It supports different rendering engines from Preact to Hyper HTML, etc. You can take since the latest version of Angular, you can start experimenting with taking an Angular module and then turning that into a web component. So you can take multiple of your Angular components, stack them together, and then expose that as a custom element. Vue does the same thing. There are projects for React, Preact, and stuff looking into this. There's also the new kit around the block called Stencil, which kind of made a lot of fuzz. It's built by the Ionic team. And there's a bunch of these things. And the goal here really is to allow you to pick your favorite way of writing these things and then sharing them with others so that they can pick their favorite tools. This is not meant to replace Angular and React and Vue and stuff like that. They all have their use cases, and they're made for you to build complex applications. But they're not really designed to share UI concepts with others. And that's really where web components come into play. And with that, let's stop talking theory and actually start building the last date picker here on stage to write a bit of history. Or if I look at my time, we might actually not have enough time for that. So instead, let's build a rating component. Because I feel confident enough to do that right now. And before we start, I need to give you a bit of background. If you've seen my Twitter profile, you might have seen this picture. So I'm part of a group called Onesie.js. We're just a bunch of JavaScript developers who love the community and also love wearing onesies at events. I didn't bring mine this time, but I'm typically wearing a panda onesie. So I figured I want to get your feedback about the talk later. So we're going to build a rating component that you can rate how many pandas worth was this talk, or pretty much any emoji. So we're going to call it emoji rating. And in order to build this, we're going to use a tool called LitElement. So LitElement is still pretty new around the block and is still in active development, but it's written by the Polymer team. And it's just a simple base class for creating custom elements that is powered by lit.html. And I'm going to talk about that in a second. But it's one of these things that the Polymer team is working on to make the adoption of web components easier without actually having to dive into Polymer. It uses web standards, which means we don't have to compile anything. We will use module bundling, but that's simply because we're using I forgot how they're called, but the normal module syntax that you're used to from Node and things like that, instead of actually specifying full paths. If you're not familiar with lit.html, it's powered by tag templates, so string templates from JavaScript, and it's powered using HTML templates. So that means it's very efficient in re-rendering and creating multiple instances. If you want to check it out, that's the GitHub repository. And again, I'm sharing the slides later, so you can check out all of these links. But let's actually start building this thing instead. All right. By the way, let's load it again, but it reset the code. So let's ignore this. Cool. So that's the wrong project. Nope, that's also not the one. This is the one. So I already have some code, but it's very much boilerplate code. So what I installed is I created a basic HTML here. And what I'm loading in here is the web components JS bundle, which is just all the polyfills that we might need. And then aside of that, I don't have anything in here yet. And I'm using Parcel to kind of bundle this during development so we can easily test this. So if I run npm start here, it's going to kick off Parcel, as you can see here, and start a development server. So we can click on this. No, alt click. There we go. And there's nothing on there yet because we didn't create anything. So if you developed with Parcel before, or if you've watched Stefan's talk yesterday, you'll know that you can simply load any script here, and it's going to start the bundling for this. So that's what we're going to do. And if we look into emoji rating, it's a completely empty file. So let's start with actually creating a class. So we're going to create one called emoji rating. And we need to extend this from something. Since I said we're not using HTML element directly, but we're using lit HTML, I'm going to import this from the Polymer lit element module that I already installed because I didn't want to rely on the internet for this. And then we simply extend this from that. And the lit element has a sort of interface you want to implement. And one of these is the underscore render function. So anything that starts with underscore in lit element will be internal kind of functions, and everything that you add as without an underscore will actually turn into a method on the custom element later. And in here, we're going to return lit HTML templates. So the way that works is we just write HTML here. I'm going to import that from lit element. And then in here, we just write HTML. And I actually have a Visual Studio Code extension installed. So I get full autocomplete here and everything. So you don't have to worry about that. But the difference compared to JSX is that there's nothing here that needs to be converted later. This would just run if I would specify here instead the path to the actual bundle. I wouldn't even have to bundle this. It would just run because it's using web technology. So I said we're creating a rating. So we're going to create a role range here. Let's add a class called rating. And for now, let's just write something like hello here to see if it works. And then we go back into the index HTML, and we can start using this. So emoji rating, save this, switch back, and so I created the class, but obviously I didn't tell the browser about this. So we want to do custom elements.define, specify that it's called emoji rating, and then pass in which class should be instantiated. And now we have the hello here. So far, so good. Now, we want to have some properties so we can customize this. And the nice thing about lit element, and one reason why I like using it, is because lit element does the connection between attributes and properties for you automatically. And all you have to do is define a getter called properties, and return an object here that specifies which values are available and what type they are. So we want to have a min value, a max value, want to have a value, and then an emoji would be nice so we can modify which emoji it is. So that's of type string. Nope. And we want to have some default values, and that's what we do in the constructor. So I'm going to create a constructor here. Need to call super since we're inheriting. And then all I do here is really set this to min, this max to 5, value to 0, and because we're going to use pandas by default, I'm going to use panda here. And now we have all of these available in the renderer. We could just call this dot on them, but the render method is also nice enough to pass all of these in here, so we can just grab them. And for now, what we're just going to do here is put in the emoji here. So we're just using string interpolation like any other string template would do in JavaScript. And now we have the panda emoji here. So if we go back, let's actually change that here. So if we open the DevTools and we click on this, this is how it looks like right now. So we see here the shadow root because we're using the shadow DOM. And then in here is the HTML we wrote, and we see the panda here. If I select this and I open the console down here, we have access to that. So let's store that as $0. And then we can set the emoji, for example, to heart's eyes, for example, and that updates automatically. You can see it doesn't actually set it as an attribute because right now, it's only doing the reflection in one way because that's typically what you want to do anyways. But you can kind of enable that as well if you want to. Cool. So we have that. Let's actually build this as a rating tool. So one thing we need is we need a list of emojis. And I'm just going to do a small trick here. So this way we just get the exact number of emojis that we want. And then I'm using, since we're using lit HTML, it has a couple of helper tools that we can use. One of them is called repeat, which is just really good in efficiently re-rendering a list. And we can pull that in from the lit HTML module. It's actually in its own path, so that you're like, they really want to make sure it's a small memory footprint, so you need to manually pull these things in. And then we're gonna repeat here over the emoji list. And we're gonna have to declare a function here that works similar to if you develop with React, the keys, for example. Since ours is anyways just a list that doesn't have like any good property that we can figure out on which values changed, just gonna listen on the index. And then I'm gonna pass in a function here to render emoji. I'm gonna bind to this. And then we need to define this. So it's called render emoji. It's gonna get an emoji and an index. And then in here, we can return, again, some HTML template here. We're gonna call it emoji. I'm gonna put an emoji in here. Oop. Save this. And now we should have, what did I break? Let's see, let's open this. Nothing here. Oh, yeah, you should repeat max and not value because value is 0. There we go, now we have 5 pandas. But we want to obviously make this a proper rating component. So one thing we need is a style called, just like a CSS class active. And what we're doing here is if the index is less than the value, then we're gonna do the active, otherwise we're just gonna keep our class. And we can just use here string interpolation again, and we're just gonna write active. And we're also gonna keep the index property here for later. And if we refresh this, we see that right now they all have only emoji because none of them is active. But let's actually start having some style here. So I'm not going to write that CSS right now. Let's format this. And this looks already way more like a rating component. If we select this and we now do something like value, for example, we can set it to 4, and we see we have four pandas. But you don't want to ask your users to open the DevTools and play around with this. So we want to listen on click events. And the way we do that is by, and this is again similar to things like React and stuff, we can just listen on the on-click, and then we do a template here. And in here, we just write like this, handle click. We're going to bind it again. And then we need to implement it. And we're going to get an event here. And our new value is going to be parsing the event.target.dataset.index, which is exactly the value we're setting here. And then we're just going to add a 1 to it. And one thing I just want to do for simplicity, so you can also give me 0 pandas if you want to. I would be sad about that, but I want to give you the option. If it's the same value, I'm just going to set value to 0. And otherwise, I'm going to set the value to value. Save this, refresh. And now we can start clicking here, and all of that works. The thing, though, is that you also want to, like in a normal input element, you would be able to listen on something like on change. So ideally, we should be able to go here, create a script tag, and say, hey, I want to grab the emoji rating, and then I want to add an event listener for change. And what I want to do here is I'm grabbing the event and then console logging event.target.value. So this will work with an input element, so why shouldn't it work with our rating component? So how do we implement that? All we have to do is I'm going to turn this into an async function because I want to wait until the component has been re-rendered, and lit element actually gives you a render complete promise that always resumes when the rendering has is always fulfilled when the rendering has been finished. And then afterwards, I'm going to dispatch an event. I'm going to just use a built-in custom event called change. And then I need to specify some detail, and that's just going to be our value. Oh. And I always put a semicolon there for whatever reason. We refresh this, and now we see it's actually console logging the values that we specify whenever we click here. And the nice thing here now is with this component, we can, for example, specify all the additional ARIA tags, for example, to make this properly accessible. And then the people who use it never actually have to worry about this, like adding accessibility to it. It just works out of the box, just like, for example, an input element would work out of the box. What if I want to style this? So I'm using in here the CSS custom properties, or you might know them as CSS variables. And this allows me to define a very clear set of things that I like an API almost that I allow the user to modify. Like I don't want you to modify the entire alignment and stuff like that. I just want to be able to allow you to modify how this background looks like. So we could, for example, give this a class called red. And then in here, we can create a red. And all we do is we set emoji rating unselected color, that's the name I gave it, to red. We save this. And now you can see it's actually red for all the emojis that are unselected. And therefore we can expose kind of like a direct thing. And this is really nice for teams like a brand team that maybe you want to expose how big a button is, but you just want to do that via CSS and instead of like specifying it in the HTML, or you want to just allow you to like change the color but nothing else. This will allow you to do that. Cool, so we have this. I actually rolled this up and published it to NPM so we can use it later in an example. But I want to talk about something else that a lot of people always keep on asking questions. What about Stencil? So if you're not familiar with Stencil or never heard of it, Stencil was written by the Ionic team, and the Ionic team basically creates a bunch of UI tools for building hybrid apps. And they built Stencil as a compiler that generates web components. So that means, contrary to what I just showed you with lit element, they have their own syntax, they have their own build tool that you need to run this through, but then it will generate web components. And it's built by the Ionic team to bring Ionic to more than just the Angular framework, because that was their initial vision, and then they started building everything in Angular and kind of got stuck in there. And now they want to bet on web components to allow you to build a hybrid app in React and still use their tools, for example. And it's heavily inspired by things from different frameworks. You know, they took some things from Angular they liked. They took some things from React, like JSX, that they liked. And therefore, it uses TypeScript, it uses decorators, it uses JSX. If you want to check it out, go to stenciljs.com. But I figured I'm also just going to give you a quick demo here. So if we're going back, let's close these two. So what I did is I literally just followed the getting started instructions, which is git clone the following project and remove the thing. And then let's close the dist folder. And then this is how your structure looks like. So you get a default component here, get an index and HTML. We're going to npm start this to start the dev server. It's going to do the first build. And this is what we see. And if we look at the index HTML from this, this is the component we're using and the values. And if we inspect the component, this is how a component in Stencil would look like. We have decorators, which are still being spec'd, but they're heavily used by things like Angular and Stencil and stuff, so they're likely gonna not change too much anymore. And then down here we have a render function, so similar to what we did with lit element, but here we're returning JSX. So it's a slightly different syntax. So let's turn this actually into a my alert box, because we were talking about alert boxes earlier. We're gonna again be a nice citizen here of the web and actually specify the role of this. And we're gonna create a title here. I'm gonna have an alert title. We can give it a default value like alert, and then pass it in here. And then I'm going to use because we're using the shadow DOM here, we can use the slot attribute. So I'm going to keep this, and let's add a paragraph before saying something like, hey, something went wrong. And also add a footer, like, let's solve this. And then you'll be able to kind of, whenever you use this component, you'll be able to provide the details in between these two. So if we go back into the index HTML, we obviously need to change this completely. It's called my alert now. And then in here, we can now give information. So we could put a div tag in here. And then inside, we could put a paragraph and say, or let's do this like a detail. And then we write like hello here. Save this. Now we actually have this details thing here. And then in there, we have the hello. And so far, so good. But how does this look like now if we inspect this? We see the shadow root here, and we see the details thing that we used right underneath it. But then if we open this entire thing, we see the slot. And if we open the slot, we see it actually refers back to this property here. So why is the browser showing it this way? Why doesn't it just throw this in there? That's the way the shadow DOM works, and the reason why this works is that way is if we create now a global style here, and we say, for example, we want to use cursive font, and we save this, we'll see that the paragraph that we wrote in our own page suddenly has this cursive font, but everything else stays the same. It's not being touched. And this works the other way around as well. So if we go into the My Components CSS, and we say here as like, hey, every paragraph should really be a font weight of 800, and it should be of color orange. And we save this. We see, again, the other thing is not being touched either. So we have a full encapsulation of the styles here. And that's the really powerful part of the shadow DOM, meaning you can provide as an author of a component, you can provide, like, these are the places that you can play around with. Everything else I'm controlling. So you can have multiple slots and name them so that people can get a better idea of, like, hey, this is where I'm placing whatever. And therefore not rely on, like, oh, I have to put the things in the right order and things like that. Cool. So we have that. One thing I wanted to show you is similar to lit element, there's a way to reflect back the attributes. So we can do here true. And now what this will do is it will not only reflect attributes to properties, it will also do it the other way around. So if we grab the component here and then do alert title, to like something like, oh no, we actually see that it's been updated here as well instead of just in the DOM. Cool. That was the Stencil demo. Now as a last thing, I figured we should actually use a web component. And in order to use it, I built this thing to vote on my talk later. And it's not fully done. So this is the deployed version, but it doesn't actually allow you to deploy it, like vote actually on my talk. So we're going to change that. So the project is written in Angular. It's just a default out-of-the-box ng-CLI project, so I didn't do any magic there. I will show you two things that I did. did do, so this is the project. We're going to start it off in the meantime so we can start compiling. Two things I did. On the one hand, I went into the TS config. Where is it? And I changed the target to ES 2015. And the reason for that is that that web components require you to do ES 2015 class inheritance. You can't do prototypal inheritance. You have to do this because those are built-in native classes and not functions, and therefore you have to do this. There is an adapter if you actually still rely on down transpiling to ES5. There is an adapter that you can use, but I wanted to show you the proper way that ideally we can start doing this. And then the other thing that I did is in the index HTML, I'm including, again, the polyfill. And I npm installed my component that I used, that I published, which is the same code. Like, you can check it out on GitHub if you don't believe me. It's the same code. So if we go into app-component.module, this is where we want to do the first changes. So let's first look if the app deployed. So here we go. And open the DevTools and enjoy Dancing Panda here. So the first thing we need to do is we need to tell Angular, hey, there's custom elements around, because Angular will try to verify that every component you're using is indeed a component that exists. So for that, they use schemas. So we can import the custom elements schema, which comes with the core library of Angular. And then we just say, hey, actually use this. So from that point on, Angular is not going to bother trying to verify that every component is an Angular component. They might see like, hey, there's one I don't know, so I believe that's a web component. And then the other thing we need to do in this file, or we could do it at any point really, but I'm going to do it in this, is I'm just going to import the emoji rating, and that's all we have to do here. So now we can go into the app component HTML, and we can load in our emoji rating here, save it, and if this refreshes, we now have the component here. It works, it refreshes, changes, but if we look into the app component TS, we actually already have a current value property, so we want to bind to that, especially because I want to set the default value to 3 here, so you're hopefully more likely to upvote my talk. So what we do is we do it like every other component in Angular works. We just say, hey, bind this value to the current value. And this is how you do it in Angular. You could do the same thing in Vue, for example. And now we see that the Panda by default has 3. Now if we change it, it's not reflecting actually down here. So it's clearly not updating. For that, we can listen on the change event, and this is how you do it in Angular. And we're going to create a handle change function that we're just going to pass in the event to. And that one doesn't exist yet, so we're going to write it. And in here, we grab the event, and then again grab the value. This event.target.value, similar how we did it earlier with a native kind of add event listener. And then we set the current value to value. One thing we have to do here, because some browsers, based on the polyfill, the Angular change detection is still breaking. But that's not a problem with web components. That's a problem with the polyfill right now. And there's an open GitHub issue for that, so that's hopefully going to change. But in the meantime, we actually need to manually trigger the change detection. So I'm going to import this here, and then just say, hey, change detection, detect changes. Save this, go back, and now we see, if we reload this. Oh. Oh. Thank you. It's nothing like crowd debugging. So now we can see it actually kind of keeps it up to date down there as well. So let's go here, remove these 2 checks, save it. Commit this, because I want to just push this, And cool, so this is going to trigger off the deployment on Netlify, and hopefully we have that by the end of the talk. In the meantime, let's wrap this up. So I want you to think about web components whenever you realize you have to share UI with other teams, with other projects, sub-projects and stuff. That's when you want to start thinking about, hey, is it worth building this as a web component? Because web components are not there to limit your framework choices. They are not there to kill React or Angular or anything. That's not the purpose of web components. It's just solving this problem of actually sharing UI between projects so we stop writing redundant code and actually can focus on quality things. Because ultimately the goal is that you can pick your favorite tools and let others pick their favorite tools. That's really the goal of web components. And hopefully to write a one date picker to rule them all so we can stop writing these. At least have one material design one or one with another design philosophy, and ideally one that we can just style ourselves. But instead of having over 1,000 date pickers. If you want to learn more about web components and see some examples, webcomponents.org is great. Most of those actually still use HTML imports, but it's still a good view of looking at a couple of existing web components. CustomElements.everywhere is a great website if you're now curious of using web components, but you're not sure how to support in your framework of choices, because Angular and Vue actually have perfect support. However, things like React, Preact still have a couple of issues depending on what you're trying to do with your web components. But the nice thing is this runs against a bunch of different popular frameworks. It runs tests against them, and it also keeps track of all the related issues. So if you see something doesn't work with it, there's likely a GitHub issue already existing. You can check what's the status there and kind of keep up to date with that. If you want to compare different implementations of web components, there's a web components to-do that has versions for Skate.js, for Stencil, for Vue, for Angular Elements, and a bunch of other things, Polymer. So you can look at how the code changes, which one seems like the nicest philosophy for you. So there's a bunch of resources. I wrote a blog post how you can get started and even publish to NPM a web component with Stencil. The slide's going to be on this URL, and I'm going to tweet out all the URLs after this talk. The emoji rating code is here. Webcomponents.org is a great resource, and custom elements everywhere. And that's the URL for web components. And now let's hope this actually deployed. Let's refresh. Yay! So cool. So yeah, you can go to this URL and vote for it there, or you can just throw in a green piece of paper. And with that, I would like to thank you all for your attention. If you have any questions, I'll be down at the Twilio booth most of the time, so just come by there, ask me some questions, or ping me on Twitter. My DMs are open, or shoot me an email, whatever you prefer. And I'm happy to help you out and answer your questions. Thank you all.